Hello guys, welcome to another video. So today I would like us to look at the data types. Why are they important and how can we use them in our application? So let's jump right into it. Okay, so first things first, let's break down the terms. So what is data? Okay, data refers to processed information. So data is basically unprocessed information. Why do we need that information? To draw up conclusions. Or to make decisions. Okay, so for example, say I give you 1, 2, 3, JHB 0001. When you see it, it's just words and numbers. They don't actually mean anything until you process it, right? Once you process it, you end up with what? With address, right? And what is address? Address is basically information. It tells you where something is stored, where the house is located, and so on. Okay? Then we have data types. So data types is basically containers. Container that is used to store data. That's all it's used for. It's used to store data. Okay? Why do we need data types? So that we can sort out the data and we should know how we need to process it. So say for example, the government wants to build us houses. That's my house right there. It's a bit ugly and not fancy, but yeah. The government comes in, we want to build houses. So what do they need? Before they can build houses, they need data. How many people need houses? Right? Where are we going to build these houses? And how are we going to build those houses? So what is that? The quantity of people who needs the house. Number of people who needs houses. Right? Then they need to know where, which is what? Location. They also need to know how are they going to build these houses. Okay? All of this will be what? Will be data. So what is this? It's numbers. We speak in numbers when you speak about the number of people who need houses. Where is just words or phrases which actually tells us where this thing is going to be built. Same as how. Okay? This can also be referred to date, location, which is what? Address. Okay? Cool. Now, for us to be able to categorize this, we need to understand which options do we have of categorizing this data. So the data types, they actually have what is known as data groups. We have primitives, then we have non-primitives. We have primitives and non-primitives. So primitives, they actually what comes in bundled with your programming language. So in real life, we'll have things like rocks, stones. You can consider those primitives because they belong there, right? We didn't make them, we found them there. Then the primitives that actually grouped into two. We have numeric and non-numeric. We have numeric and non-numeric. Then inside numeric, it's also divided into two. As far as you know, you have whole numbers, right? You have your 1, 2, 3, 4, 5, 6, 7. Then on be fractional numbers, your 1.5, 1.12345. Those are your fractional, your decimal numbers, right? So it will be what? Your integers. Then you have your float. Your integers, that basically your whole numbers. Your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then your float would be your fractional numbers, your decimal numbers, your 1.1, 1.2, 1.3, 4, 5, 6, 7, and so on. Then under integers, we have the actual data types. So what do we have? We have byte. We have what? Short. We have int. And we have long. And then for float, we said those are your fractional numbers. We have what? We have float. And we have your double. Okay, these are our data types for integers. So these are our data types for numerical values. Now for non-numerical values, we have two. We have your Boolean which is your true or false. True or false. Then you have your char, which stores your alphabet, your numerics, your special characters, but in singular. Okay? Then we have the non-primitives. These are what's built on top of your programming language. You have your strings. You also have your arrays and user-defined classes. Defined class. Okay? If you don't understand what a class is, I have a whole tutorial video speaking about classes and objects. I'll leave the link in the description below. Okay? I won't get too much into the non-primitives. We're going to have a separate video where we go through them. So for this one, we're going to focus more on the primitives. Okay? Now, let's look at them one by one. We spoke about a char. Stores single value. Which is your character. Can be your alphabet, can be your numbers, can be your special characters, your ampersands, your full stops, and all of that. Then you have your byte. This one stores from -1 to 8 to positive 1 to 7. Then you have your short -32,768 to 32,767. Okay, then you have your integer, which is int. This one is a bit bigger. It holds up to 2 billion. So it will be minus 2 147,438,648 to positive 2,147,648,647. Okay, so if you can check, int is much greater than short. Short is also greater than byte. Then you have your long. This one, I don't even know what this number is. It's extremely large. I think it's from 9 quadrillion, quintillion, or quintillion. Yeah, whatever that number is minus 9 2 2 3 3 7 2 0 3 6 8 5 4 7 7 5 8 0 8. That's from the negative. Yeah, that's a very big number. To positive 9 2 2 3 3 7 2 0 3 6 8 5 4 7 7 5 8 0 7. Okay, so now you probably ask yourself, what's the difference between these ones? So these guys, they are similar in a way that they both store whole numbers. They both store whole numbers. Okay, now these data types, look at them like your bottle of beer. You have your 440 can, you have your 750 ml, you have your 1 liter, and so on. So if what you're looking for is short, right? You wouldn't buy a 750 ml if you can only drink 440. You're not a drunkard. Okay, you're not like us. Us, we drink like 10 liters. We really drink. We don't play games. Okay? Then you have your fractional, your floats. Okay? What are those ones? We have float. Then you have your double. Okay? This one, it can store up to 6 decimal digits. Can store up to 6 decimal digits, which is after the full stop. The numbers that follows after that should only be 6 digits. Then, sometimes you deal with very large numbers, right? Then you are in a situation where float cannot accommodate for those numbers. The capacity has been maxed out. Then you can use double, which can accommodate up to 15 decimal places. Digits. Okay, then last but not least, we have Boolean. This one, it's either a true or a false. That's it. It's not that complicated. It's just a true or false, that it is actually options. Okay, so now let's take a look at this in the real life coding example so that we can try to make more sense out of it. Okay, so let's look at the coding example of the data types which we just spoke about. Okay, we spoke about data type car, right? That's for a single. We spoke about car, which is a data type to store single characters, right? It can be your number, it can be your alphabet, special characters, and so on. Okay, then we spoke about whole numbers. Inside whole numbers, there's byte, short, integer, and my long. Then we spoke about whole numbers, right? In whole number, we have short, we have byte, we have int, we have long. And the difference between these data types is the capacity. One can hold more values than the other one. So we spoke about byte. So how you declare your variables in Java, you must first provide the keyword for the data type that you want to create. That would be byte. Then you can give it any name that you want that makes sense to you. Then you can give it an actual value that you putting data into that container. Okay, so for example, we said this one can store up to 127. So if you change it and try to give it more than what it can allocate, then you get an error. It starts complaining. You can't put in more than the actual capacity. Okay, then if you're dealing with more values, because sometimes in real world you tend to deal with much larger numbers, then you can move to a short, and a short can store up to 32,768. If you try to go beyond that, same issue, it's going to complain. Okay, but these two data types, they are very rarely used, and especially when you're learning programming, in most scenarios you might find yourself not even using them. You might find yourself using int, which is the most commonly used, because the numbers that we tend to use when working on applications, they tend to be slightly a bit higher than byte or short. Okay, then we spoke about long as well. So if you can check the range here, it's still correct according to integer. And what did we say? We said long can store higher values than int, right? Than integers. Sorry, we spoke that long can actually store higher value than int. Okay, but now it's complaining. Why? Because by default, Java tends to think that this number actually represents an int. So how do we solve that problem? You tell it by using the keyword L. Can be either be a small letter or a capital letter. It's just self-preference. You can choose whichever that you want. If you can check, now it solved the issue. Similar to what we have between int and long, we have the same issue with float and double. The application by default, it thinks that, okay, 1.5, it's a double. But then you use what? You use F. You use F to say, no. Change this value into a float. It's not a double. Okay? And we said it can only store up to 6 or 7 decimal digits. Okay? And then double, it stores slightly higher than that. Okay? And then we spoke about Boolean. So you say Boolean, you give it your name, you give it a value. We said can either be a true or can be a false. Okay? Then for false. Then what you can also do, you can also put in a condition. For example, I said 1 greater than 2. So what this thing is going to do, it will say it's 1 greater than 2, which is false, and it's going to take false and assign it to this value. So it's going to say, no, this is false, and attach it into my container. It's going to put in a false. And then if I change this and put it like that, it's going to say, no, this is true, assign true into this value. Okay? Okay guys, we have reached the end of our video. I really hope this was helpful, and if you liked it, hit the like button, and don't forget to subscribe and share with your friends and those who know me and those who don't. See you in the next one.